All right, this is we'll be going through the behaviors of Grignard reagents, and this is coming from organometallic course, that is 360 organic chemistry. All right, so that is the case of CBU, the course code, but it's important also for other programs. All right, so that is it. Let's go and we see how we can at least answer one or two questions from there. All right. So, what we need to know is that Grignard reagents, these are just reagents that actually contain a metal and also a halogen element. All right. So, a Grignard reactions, it's actually starting with there will be a carbon from the word organometallic. The carbon now interacting with a metal. The case of this is magnesium. So we'll see how this bond is formed. I would do the mechanism and you'll be able to understand. So what I'm trying to say is these Grignard reagents, um, they are of this type. They can be of this type, like you can find a metal which is magnesium reacting, let's say, with the bromine. Then this side they have an alkyl group where they are bonded to other elements. All right, so this one they will be there to transfer this to a compound. So suppose they were reacting with let's say pentane. Okay, let me just draw this as pentane. So what will happen is that the pentane will be attached there, then they will remain there with magnesium, which is 2 plus like that, then plus this will cause us with a bromine like that. So that's how we'll be finding this. So it means that the Greek reagents, these reagents, they'll be there to transfer this group to other molecule and different products will be formed, especially alcohols. We'll see, we explain the behavior. So let me demonstrate what we call the mechanism on how they will be attacking these different groups. All right, so the mechanism, let me explain the mechanism and you understand how they really um, how they attacked the how they are able to transfer one group to another element and to another group. All right, so the first thing what they do, these guys, is that I gave off the type the Grignard reagents with it's bonded to an alkyl group. It has an alkyl group, a group, then it's also bonded to it is also bonded to a metal, that carbon group, then a metal in this case is magnesium, then with some bromine there. All right, so I'll say some bromine there. Okay, this bromine is always negatively charged, highly electronegative elements, so we understand this. So how is this formed? So now I want to demonstrate. So step one, so what is going to happen is that the first thing that we do is, first, these guys, before forming this, we find this um we find an alkyl group bonded to a halogen element, let's say X. Then we want to add with this magnesium so that we can form these reagents we have been talking about. All right, then what we are going to form is, what will happen is that first of all there will be what we call partial charge formation, such that this one is showing its behavior. Now it has an electron that it can use to bond, then it is also negatively charged like that. All right, so that's what will be formed. So let me just demonstrate to you. Let me demonstrate to you what I'm trying to say. So we'll see an element, we'll see this other group, like disassociating with this halogen. So the halogen has the element, the electron that it can pair. Then also the magnesium is also, now because it's attracting now it's attracting the halogen so that it can bond. It's supposed to bond to this metal, but it is not bonding. It's trying to leave this alkyl group or a real group. So it's showing some bit of like Valentine gifts. So it also possess, it will show that I'm also ready for this reaction. So because this is metal and non-metal, so they are ready available. They like bonding. Group 7 and group 2, group 1, they like bonding these elements. So that's what will happen. This is step 1. So the magnesium will show its presence to these halides, and the halide, the rule here is just to break or to remove this halide so that the magnesium can have chance to attack the allyl group or the alkyl group. All right, so this what will happen now, I'll get these two guys which are trying to break. So the alkyl group or allyl group is bonded to this halogen. So the halogen has an extra electron there with negative charge. Then what will happen is that these now they will disassociate. Inductive effect will be performed such that they will leave this group. They will separate, in short, disassociate. How do they disassociate? This one, it's somehow partial positively charged. That's why we'll just donate its electron there. Then what will happen is that we'll have the halogen with its negative there. So I've disassociated this element. The influence is coming from magnesium, where it showed the positive charge that it's readily available to attack this. Meanwhile, it's not even interested in the halogen, it is interested in the allyl group. So what will happen now? The attack will be like um and this now the allyl group or alkyl group, it will react now with a metal. So that will be the allyl group that we have there, all right, reacting with a metal, because magnesium showed to say it has an extra electron, so we'll put that in extra electron there. So in which it actually reflected that it is readily available to bond with other elements. So that is what so these two guys, they will bond, and the magnesium, they are just sharing the electrons. So the bond is about the electrons. By the way, magnesium is positively charged for the first excitation. So that's what will be formed. So what will be formed now, the bond of these paired electron, lone pair electrons, I mean just these half electrons, they will now form a bond. Okay, so they will form now a dash bond like that. So we have formed now, the goal now has been reached, such that magnesium just wanted this allyl group, and it is still positively charged. It just shared the electrons, which it reflected at first that it has an electron like that. So from there, then what you are going to have is that this bond that we have, because this is the bond that we have formed there. All right, we have formed a bond, and now this bond is now readily available again to accept this halogen which is there. So what happens is that we have this bond R, all right, and magnesium like that. Let me in fact attach them so that we see that these guys, they are fully bonded. All right, so what I'm trying to say is magnesium, let me write the allyl group so that the way I've been presenting. So let me write, so we have the allyl group there, all right, bonded to magnesium. Okay, so magnesium, it is having what? That positive charge. So that positive charge will attract the one which left, which is the halide with the negative charge there. So this halide can be bromine, chlorine, whatsoever element. So that is it. Then from there, then once this bond, so it's more like this, now they will bond. And what we are going to form is now the Grignard reagent, which is RMG, all right, then the halide there, just like that. So this is the Grignard reagent. So this reagent, we'll see how it will be used to form alcohols, to form different products. So let's see. All right, so this is the mechanism done. So there are two types of Grignard reagents that will be used. All right, so there are two types of Grignard reagents that will be used. So the first reagent is we have 1, 2, 3, 4. Okay, it's a bromobutano, butane, bromobutane. So we have 1, 2, 3, 4, 5. In fact, it's 5 elements. So say this is bromopentano or 1 pentane, something like that. You can call it like that. So we use bromide, like I've been explaining that that our Q group, which is now this case. This is the R that we had. So then we have the magnesium that we are trying to attach to that our Q group. Then in the condition of what? Ethers. So what are ethers? We explain what are they. So what will be formed is that these guys now, it will come and bond between there. So that's the rule we made at first. Check. Where the allyl, there R is this allyl group, then the Mg will be on the middle, then the alkyl will be I mean the halide will be on the other side, which is the bromine in this case. So form the same thing. So say one, two. All right. So here a metal will be attached. All right. Then a bromide there. Okay. So this is the first reagent. This reagent will be used, this form of reagent using the Kikule representation of carbons. So this presentation of like allo dash like that is what we call Kikule representation. Then this reagent will be used to transfer this to whatever element this guy will be reacting with. So that's a key point that you need to understand. All right. So coming to the second one, like of all right. Okay, so I'm writing this benzene ring. Okay, so this benzene ring, suppose it's bonded to bromine. I like using bromine because even your lecture note uses bromine. So we have this magnesium in the presence of ether. So sometimes it's not only ether, even hexane, like all the alkanes they use pentane, they can use as conditions to form these reagents. So it's not only that ether. All right. So what will happen? The law is also applied. The magnesium will come bond between. What is the magnesium is interested to bond with a metal. That hence the name organometallic. Organic, which is the carbon bonding to a metal. So we still have the same. All right. So I can light as a link like that if I want. We understand the conjugation that is so fast. So it's as good as me lighting like this. Or if you want, you can light those allos that were inside. There's no problem. There's no harm. So we write the magnesium there and the bromide. Okay, so if this guy is to react, it will just transfer this part, then itself it will remain disassociated in aqueous like that. So these are the two reagents that are commonly used. So let us see now different reactions that these Grignard reagents can undergo with and the product that is formed. All right, so key reactions. All right. Key reactions of Grignard. All right. Okay, so these are the key reactions. So the first key reaction that we have is um, these Grignard reactions or reagents, they react with the expo side. So they react with expo side. All right, so what happens in this? So an expo side in a circle like that, I will demonstrate also in the case of where it is actually just a Kekule represented. So like in the case, let's say we have the allyl group there, okay? This is the bond with the allyl group. So the allyl group is bonded also to oxygen. Oxygen is also bonded to some group there, which is, I mean, the oxygen is bonded like that. So this is one example of the expo side. So the conditions are that we need to have the same allyl group, which is the allyl group that we have with the different I'm differentiating this. So this is the reagent that we have been having. We don't know this group, but this group can mean something else. So what will happen is that the bromine will be there. We'll do what we call a wake up. All right. So hydrogen, this hydrogen, it will be used in the wake up to form what we call um, alcohols, because if hydrogen is to be attached there, we are here to break any bond. We break this bond or this bond, then what we are going to form is, first of all, what we are interested is to form the highest tertiary, I mean, level of carbon. It can be tertiary, primary, secondary. So what we are interested is to form the tertiary. So meaning this carbon is tertiary because 1, 2, 3. No, it's secondary. Okay, we will explain those. So what will happen, we break this bond. All right, so we'll break this bond. Okay, so this bond now will break. So we'll have the other there. All right, so with the oxygen there, the oxygen is negatively charged there. So if I'm to put oxygen negatively charged, but I won't show this, I just want to show you how they actually bond. All right, so oxygen is negatively charged there. So what will happen is that this is the bond that I've broken. So this is the point, okay? So here the R group, the allyl group, it will be transferred there. Okay. Then this hydrogen wake up, it will be used, and since this is negative, then they will form what we call an alcohol there. All right. So this is the product that will be formed. Okay. So that is it, reaction of exposites with these Grignard reagents. So the other reagents that we can have is reacting with um, the Grignard reagents will react with the aldehydes or ketones. All right, let me just write aldehydes or ketone. Aldehydes or ketone, they are just the same. They all form what is exposite, everything, they form what we call alcohols. So aldehydes and ketones. All right, so what is going to be formed? Let us see and explain one or two things. Okay, so under this, what will happen is that the Grignard reagents, they will form what we call with the aldehydes. Let me just bring a ketone. Okay, aldehydes. So aldehyde, first aldehyde, which is called formyl. So the first aldehyde, I'll call it formyl, like that. So this means that I can react it. It's bonded to a carbon here. Then we need to have what we call oxygen there, then hydrogen there. So there's a carbon there. So the carbonyl now, the first carbonyl is formyl. Then that is it. So this first carbon is also called formaldehyde, just formaldehyde. Like it's the first carbon, it's the first aldehyde because it contains one group there. This is C, is a part of function group. So we call it formaldehyde. There's also what we call acetaldehyde. So in the presence of so reacting these now, there's R there from the Grignard reagents. Then the reagent itself is bromine, like that. Okay, so plus the wake up hydrogen that I demonstrated how it forms. Then what will be formed is that the thing that will be formed is the product that will be formed. The goal is to break this bond. Once the bond, remember the goal, each and every part, like you are coming, this was a bit of cyclo something, cycloether. So a cycloketone. So like what we need to do is to break the bond. The goal is to break the bond. These guys, they are there to attack a bond. So this bond will be attacked. All right. So once this bond is attacked, this one need to go there, and also this bond will be empty to come there. So that will be now, that will give us R, the from the original compound. Then okay, like that. Then there's this bond now which was there. Plus this hydrogen wake up, we said it will be bonded with the third hydrogen just to demonstrate. Otherwise, there's also water involved. But for the sake of explanation, this is how we should end up with the product. Then this bond which was there, this bond now is the bond that will be used to attach this allyl group. All right, this allyl group from that guy. Then there's also a bond which had H. All right, so those are the things that will be happening. So this H is that H we had there. So that is it. This is how you should be actually concluding this. All right, let me demonstrate again with the esters. So by the way, I forgot to say something. When you see a functional group like this, a carbon bonded to oxygen like that, then they are alkyl groups there. So this is what we call a ketone. All right, but when there's just H there, it ends there. That's what we call an aldehyde. So you should differentiate the two. So ether, I will also explain. Ether, it has just double bonds like that on the middle. So we explain all those things. So that is it. Let me now demonstrate what happens when these guys react with the esters. So esters, I mean esters, not esters. Okay. So they are also what you call ethers. So I hope to give you an example for that if they don't react, I guess. So that is it. So let's go and see how we can manipulate this. So the first thing that we need to do is, I'll give an example of an ester. An ester is just whereby there's double bond. We have allyl group, then we have a carbon there. All right, let me do this. All right. So we have an allyl group or a Q group there. Then um, with a carbon there, the carbon that will be bonded to two oxygen, the other oxygen is bonded to that, then is also bonded to another allyl group. All right. So in short, the carbon group. Then from there, we react now with what we want. So we have the allyl group from the Grignard reagents, from our favorite reagents. Then we use bromine as usual. Then there's also a hydrogen wake up like I've been demonstrating. So from there, then what are we go? The goal is to break this bond. Once we break that bond, we'll have R, all right, R. Then the oxygen will be there. Remember this hydrogen wake up, let us attach it like that. Then that bond we have broken it. Now there's also another piece which has come in, this piece. So this is where now the RU group it will be attached there. Okay, then we had the OR. I mean, here, since this was supposed to be OR, you remove that. This is no longer. What you are interested is to form the alcohol. So that's a go here, is to form the alcohol. Remove this hydrogen and the bond will just come between this. And the bond that is between the carbon on the middle is what we call the R that we found there. All right. So the goal here is that you just form for the esters, aldehydes, ketones, you always form a carbon. What's this? Alcohol. So here, this alcohol is what is a secondary because it's bonded to what? 1, 2, 3. So you just look at from here, it's secondary. Here, it's bonded. This carbon is bonded to what? 1, 2. So it's just um, secondary as well. So make sure that the oxygen is also like it disappears for the case of esters because there were two oxygens there. All right. So more reactions I can demonstrate. So the reaction of exposites, like now the case of we now demonstrate the real reactions than in structure in calculated form. So I can now start. So reaction with exposites. So exposite are things like the hydronium, so which is this one. All right, the hydronium, which is the H3O. So suppose we have a Grignard reagent bonded to what group is this? 3, I mean 2. Okay, 2. Then we have also 2. All right. Then the oxygen, which we had. So then it's also bonded to magnesium like that. Then the X group, which is the halogen, then plus we are reacting with H3O. What are we going to form? So what will be formed is that we are going to have the goal is to form alcohols. That's the reason why. So the hydrogen from wake up now it will be found from this guy. All right, the hydronium. All right, is that clear? Good. So what will happen is that I'll bring the same thing. Remember, this guy is used just to remove. It's just used to bring that part which is there. So what they do, these guys in bases form, if they are to put in base media, I mean solution, they will make alcohols by getting what is less. I mean the more basic substance, they will get hydrogen and attach there, then them they will leave. That's how they will be behaving this way. Okay, so that is it. So now the demonstration will be the R that we had there, okay, this alarm and the group that we had there, okay, 2. Then again we have 2. All right. Then we have that from hydronium will remain with water and the H will be attached there. Then plus this guy will just disassociate, magnesium plus 2 plus, and also the X which is negative. This X we had. This they will dissociate. The goal is just to form exposites. You so I demonstrated that they form water. I mean they form alcohols. So you tell me what type of alcohol. Is it a tertiary, secondary? You guess it from there. All right, so that is it. Let's go to another reaction. Let's say we are reacting these ones with aldehydes and ketones. So ketones and aldehydes, they have almost similar, just the exchange of the carbonyl group. The carbonyl group, which is C bonded to oxygen like that, that's carbonyl group. So the exchange just actually makes them difference where it's bonded. If the bond between carbon is on the middle, that will be ketone. If it is at the end, that will be an aldehyde. So let us try now to the case of this ketone now, or of aldehydes, the case of formaldehyde. So formaldehyde is just an aldehyde with one carbon. Okay, formaldehyde. So formaldehyde, I said, is just a carbon with, it's an aldehyde with one carbon. So if we were to react these, what are you going to form? So I'll bring the magnesium, the Grignard reagents, okay, the reagent that we have there. Then, like we said, in the presence of hydronium, which is the base, so what they will do is they will attack the hydrogen, they will attack this bond and form an alcohol. So what will happen is that we have hydrogen there. This ally to be attached. That's the reason. That's how they have been behaving. This case was somewhat different, but here they are here to transfer this and form this, to break this double bond and form what? And form what we call the alcohol. So that's what they would do. All right. So what I'm trying to say is they'll form something like this other group. It will be attached there because there's no way where it can be pressed. If I press the other side, the alcohol will no longer be an alcohol. So that's the reason why I'm pressing it on the back side. So this will be CH2. All right. Then the alcohol now which has been formed. That is it about so the type of alcohol, since it's only bonded to one alkyl group, this is now what we call a first, which is the primary alcohol. That is it. So reacting these guys with the acetaldehyde. Okay, why am I numbering them like this? Okay, acetaldehydes. So I need to number them like that. Acetaldehydes. Okay, acetaldehydes, actually they just look like this. Acetaldehydes looks like it's just an aldehyde with second. So we have formaldehyde, acetaldehyde. Acetaldehyde is just a second. Two carbons involved in that aldehyde. So we have, so with the acetaldehyde. Okay. So this one it involves um it involves the second or two carbons involved in that aldehydes. So I have, let's say, CH3. Okay, then the carbonyl bonded to actually oxygen like that. So this is the good representation. Then what I'm going to have is I'm reacting with a certain Grignard reagent, which is C3. All right, then bonded to metal. Okay, hope now you're able to get where we are going. Okay, hope we pause the video and try to actually conclude the reagents, the products. So this is just direct and fast forward. So the allyl group always, it can't attack there because this allyl group here, it can't attack there. If it attacks here, it will change, it will be ketone, but when we needed to form an alcohol, when such thing happen, so this, it will come there, so it will be CH3. Okay, it will bond there behind of this CH3. Again we have CH3 which was there. All right, then we have now this alcohol. All right, so we form now this alcohol. All right, so we had this one and this one, and now bring the third carbon, which is from this guy, and that will give us um CH. All right, so CH, we are forming now the aldehydes, the alcohol. The goal is to form an alcohol, remember. So what we are going to do is an alcohol will be formed like that. Let me just demonstrate like that. Okay, let me do this. Wait, I want to explain something here. Okay, okay. So we said this is the third one we had. Then this is just the carbonyl, the what's this? The functional group is that one. So we have also this methyl which has come, this methyl which has come from reagents. So it's that one. Then we have this methyl there. So the goal is these guys they are just receiving one. Remember it was an aldehyde there. All right. So this aldehyde was somehow bonded to oxygen and it was double bonded. So now how do we form the alcohol? The alcohol will be formed by eliminating this carbon because we can't bring a lot of carbons there. Okay. This carbon, if I'm to bring it, it doesn't qualify, like it will be just bonded to two things and it won't be bonded. So remember there's a bond that we want with the OH like that. So what are we putting on the middle there? All right. So the number of hydrogens are lacking. If I'm to bring that C, it means that it's only bonded to one thing and it's also bonded to this carbon. So this means that it's lacking two hydrogens. Okay, where are you getting the hydrogens? That's become an issue now because the only hydrogen we had here, it's one, so we are lacking other hydrogen. So this is why I'm saying when you see them reacting with the formaldehydes, what is formed is the second carbon, the same, we just form, in short, the same number of carbons you have found. Then these ones, these hydrogens, they just help there and form what we call the alcohol. All right, so you form what we call the alcohol. Okay, that is it. Because if I'm to bring another C there, that means this C, if I'm to bring this C, it was just from the functional group. So if I'm to bring it, so we exchange the functional groups just like that. That's the best way I can explain. We exchange the functional group. All right, and these will be attached behind. That is it. Okay, that is it. We had an aldehyde, so it will change to that. All right, so that is it. Now let us demonstrate reaction with a ketone. So how do they react with a ketone? And we'll be able to conclude from there. So a ketone. So let us see a ketone. So a ketone now looks like this. I can demonstrate the case of a ketone. Suppose I have CH3, CO, CH3 again, then reacting with a certain reagent, which is our best reagent we have been using. Then we have the X there, which is the halogen. Then now how is this going to happen? This is a ketone, so we want to see how we'll break this bond and attach there to form the alcohol. So here what I'll do is I won't finish the product. Instead, these guys, they are supposed to bring this R there once they break the bond like that. That's their duty. They are to bring, there's a bond between this carbon and this. So they are here to attach this hydrogen to this carbon. But what I'm going to do is I won't conclude it. Instead, I'll leave it hanging like this. So I'll say there's R there that will be attached on the back side. Then we have this group that we had, three. Since there are two threes there, this one and this one, I'll bring them there. I'll say two there. Okay. Then there's the bond of this carbon. All right. So say oxygen, which is now bonded to Mg. So I won't conclude this, but you can still polish it up. All right. You can still polish it up. So with the case of hydronium, now let me show you how they absorb the water. Since there's this condition, let me give you for this condition. We have R, suppose, then bonded to the alkyl group there. All right, so oxygen, Mg, X, then plus the hydronium, which is the X for side. So we have been seeing how this actually come about. So we say 3. Then what will happen is that these guys, they're already bonded there. So they will just bring this, they'll cause this, since there's this presence of a base. So this guy will come there and attach the hydrogen. So what you are going to form is R, C, open bracket CH3 2. All right, then this one now they will use hydrogen from hydronium and make an alcohol. So that's how they will form this. So let me do the last one, reacting with carbon and what they form. So reaction with so this Grignard, they will react now with carbon. So I mean carbon dioxide like that. So reacting with carbon dioxide, suppose I have this carbon dioxide, then we have oxygen, oxygen, the R, yeah, like the R that is there, and also let me write again the 2R from the Grignard reagent, then Mg, because I'm trying to balance the R, that's why I've written that too. So then X like that. So from there then that will give us the presence of ether. Okay, so the presence of ether, since this ether is a variable, so what will be formed is we can also, it causes also the addition of this hydronia. If at all is there, if hydronium or this one is there, don't worry to proceed with forming the alcohol. So the R will be there, then the C also will be there, the bond. Then this R now, which has come from that, it will be attached like I've been saying. All right, because there are two R's there. So I'll write two there. Then now, what happens that is eliminate this one oxygen, don't mind it, and it just remain with the oxygen, just like I demonstrated in the first uh, examples. So this actually will form what we call the product, which is the alcohol again. All right. So this actually marks the actions of these guys. So very important. Just go through them and master them.